So I could see right here that y is by itself. So would I use substitution or elimination if there's already a variable by itself? Would I use substitution or would I use elimination? Substitution, right? Because I can easily see that I could substitute something in for y. Remember, if both equations are in standard form, which means x and y are on the same side, then I would use elimination. But when there's already a variable by itself, I'm going to use substitution. So what you should have done is write the first equation and notice that there's a y in that equation. Remember, we talked about last time, y's tired, he doesn't want to play in the game anymore, right? We need to substitute y in with what he's equal to, is the player that's the same skill level, which is 4x plus 13. Make sure you're not just putting 4x, because that's not what y is equal to. So I literally wrote the equation, but instead of y, I plugged in what y equals to. Who got that far? Right? Give me a thumbs up. Awesome. Then I moved down negative 8x, and I see, okay, I need to distribute or multiply 7 to both of those. So 7 times 4x should have gotten 28x, and 7 times 13, what did you guys end up getting? 91 equals 11. Who got that far? Remember, part of your quiz grade is just writing down the correct way to do it. Then I draw my river, and I combine like terms. The two terms you could have combined were these two right here. And when you combine them, you end up getting 20x plus 91 equals 11. Then how do I get 91 on the other side? Subtract it, right? So we're going to subtract 91 on both sides. And when I do that, I end up getting 20x equals negative 80. Then what do? Divide. We're just solving like a regular equation. You end up getting x equals negative 4. Make sure you didn't drop the sign, because if you did get x equals 4, it's going to make the whole thing incorrect. So we know that our x-coordinate, where they cross our solution, the x-coordinate is negative 4. To get our y, what do we need to do, Tristan? Plug it in. So we take either equation. The one that's already solved is probably the easiest. Y equals 4x plus 13. And we know our x is negative 4, so I'm just going to plug in negative 4 for x. And then you solve. So you get 4 times negative 4 is negative 16, plus 13, what do you end up getting? What's negative 16 plus 13? Negative 3. Beautiful. So my solution would be negative 4, negative 3. How can I check my work to make sure that's correct? Plug it in, right? So I could plug in negative 4 in for x and negative 3 in for y, and it should get me 11 in the first equation. And when I plug in negative 4 here, it should get me negative 3 as my y. If it does, then you know it's the correct answer. Any questions on this? So this was substitution. Cool. So today what we're doing is we're looking at the number of solutions. So sometimes there's going to be one solution. See how that there was 1 point as your answer? That's one solution. Sometimes there's going to be no solutions, and sometimes there's going to be infinite solutions. So you guys are going to take out your notes that look like that, and I'm showing you what it looks like on a graph and equations. So it's a worksheet that looks like this: one solution, no solutions, infinite. And I purposely changed this one around, so this should say 3x minus 1, and this should say negative 2x plus 4. So the solution for that one wouldn't show up on that graph. Cool. So I want you guys to start by finding the solution when graphing. So we can see they're both y equals, and we can see our graphs are given, right? So since our graphs are given, I know I'm going to use graphing to solve this. Then all you do is plot your coordinates. So if I'm graphing this one right here, what's my y-intercept there? 4. So I'm going to plot 4 right there. So plot 4 on your paper as I'm plotting 4 on mine. Then since the slope is negative, am I going down or up? Down. So I'm going to go down 2. And remember, it's always over 1. Plot. And I'm going to keep going. Down 2, over 1. Down 2, over 1. Then I'm going to draw a line through it. I'm going to draw a line because it's an equation, not an inequality. Then I'm going to graph the next one. So what's the y-intercept of this one right here? -1. And then since it's +3, am I going up or down? Good. Up 3 over 1. Up 3 over 1. And you draw a line that goes through it. Your solution is where they meet. So what would our solution be here? Beautiful. 1. So the x-coordinate's 1. The y-coordinate's 2. So this would be an example of one solution, like we've been doing, right? So if you get a point as your solution, that's one solution. They touch once. How could I check my work to make sure I graphed it correctly? What could I do at that point? Plug it in, right? I could plug in 1 for x, and I should get my y as my answer for 2. Let's try the next one. I'm going to graph this one first. So what's my y-intercept? 4. And then since it's negative, am I going down or up? Down. So this isn't anything new. Down 3 over 1. The only thing new about this lesson is the answer. Then I graph my second one. So I start at -1, and I do the same thing, go down 3 over 1. I'm going to go up 3 over 1 just to continue it. It looks something like this. What do you think the solution is going to be? It's no solution. The reason it's no solution is because the lines never touch. For a brain bug, who can raise their hand and tell me what type of lines are they? They start with a P. Raising your hand. Parallel lines. So parallel lines mean they have the same slope. So if we look at this right here, see how the slope is the same right here? So their slope is both the same. Oops, so make sure to write that down. Parallel lines have the same slope, different y-intercept. Make sure to write that down. I also remember parallel, those two L's in parallel look like parallel lines. So I remember parallel because when I see it, I go, oh, this reminds me that these two lines are equidistant apart. They're never going to cross, right? When you're on the road, they're never going to cross over usually, right? Because that would be a mess. So one line or one lane is going one way, one's going the other. They're never going to cross. That's parallel lines. And they have the same exact slope. Does that make sense? The same slope, different line. Make sure to put that down. On this one, I can see, and usually it will be in standard form, so you'd have to solve it. We can see the slopes are the same, right? And the y-intercepts are the same. They're the same exact line. So if I was going to graph it, it would look something like this. And obviously, the next one is the same exact line. These two lines are called lines that coincide. What that means is basically one goes inside the other, right? Coincide means one line, they're literally on top of each other because they are the same line. So remember, solution means when they cross, they're always going to cross. They're the same line, so they're infinite solutions. It means they have the same y-intercept, same slope. So When they have the same y-intercept, same slope, we know they're infinite solutions of the same line. They coincide with one another. Does that make sense with graphing? Okay, now we're going to go to substitution. So I want you guys to try the three that are at the bottom. You guys know how to do substitution. We just did it on our ticket in the doors. So I want you guys to try these three and find what your answer is. So I'm going to give you around like 5 minutes to try these three problems. Does everyone remember how to set up the first one? You do. Does anyone not remember? No? Y'all remember? Cool. So you guys are working on those three, and then we're going to go over how the answer looks. So, Angel, how did you set up this first equation right here? What did you write on your paper? Beautiful. Who knew to do that? They're both equal to y. So since they're both equal to y, we make them equal to each other. Give me a thumbs up if you knew to do that. That's why this is going to take practice at home. This is one of the more complicated units, but it is going to take you practicing at home to make sure you got it. So all the practice can't just be in class. Then draw a river. Tristan, what would be my next step? What do you do first? What do you do first?
Subtract 10.
Sure. Subtract 10 on both sides. And so even if you did it the other way, you would still get the same answer. So you end up getting negative 3x equals 2x plus 15. Deandra, what did you do? What should we do next here? How would I get 2x on the other side? Beautiful. Subtract 2x. Even if you did it the other way, you would still get the same answer in the end. And you end up getting negative 5x equals 15. Tyreek, how would I solve it now? How would I get x by itself?
Divide 5.
What did you say?
Divide 5 with this.
So drop that negative. Yeah, divide negative 5 on both sides, and you get x equals negative 3. When I walked around, I saw some people drop that negative, which will end up giving you the wrong answer. So I got negative 3. Then, Kamari, what do I do next once I get my x coordinate? Plug it back in. So I could plug it into either one. I'm going to plug it into this one. Y equals 2x plus 25. And I know my x coordinate is negative 3. Then what do you do, Kamari? Good. What do you get? Good. Negative 6 and then plus 25. What is negative 6 plus 25? 19. So your answer should have been negative 3, comma 19. Who got that? Give me a thumbs up. How can I check my answer to make sure it's right? Plug it in. So I can plug in negative 3 for both these x's, and I should get y, 19, as my answer. Any questions on that? Okay, I'm going to erase this part of it right here. So let's try the next one. Allison, what do I do first? What does x equal though? So notice that they're giving you what x equals. So I would write, instead of x, I'm going to write what x equals right there. Then I'm going to continue writing the equation. Plus 2y equals So some people were starting to write it for y. Make sure it could change. Sometimes they can give you x, sometimes they can give you y. And Kimberly, what would I do next? So what's negative 2 times negative 2? And negative 2 times y? Negative 2y. Plus 2y, let's add. Add the rest on, equals 2. Then I combine my like terms. So I can see right here, these are both y's. What is negative 2 plus 2y? What's 2 minus 2? 0. Don't leave a y. See, a lot of people just leave. If it was 1, then it would be y. But they cross out. I end up getting 4 equals 2. Who got there and was a little bit confused? We can learn these in equations, but does 4 equal 2? Does the number 4 equal number 2? No. And because of that, it would be no solution. That means they never cross. What type of lines would they be then? What type of lines would these two equations be? Parallel lines. They're never going to touch. Does that make sense? Does anyone have any questions about that one? All right, last one. Yaslin, how do you set this up? Cool. So instead, when I write my second equation, instead of y, I'm going to plug in what y equals, which is 4x minus 11. Now I'm going to put my invisible 1 right there. Cool. Then, Angel, what do I do next? Which number would I distribute? Negative 1. Good. We move the 4x down. We distribute the negative 1. So negative 1 times 4x is negative 4x. Negative 1 times negative 11 is positive 11. Then I combine like terms. What is 4x minus 4x? 0. They cross out. And I end up getting 11 equals 11. Does 11 equal 11? Will 11 always equal 11? Yes, and so because of that, I know there's infinite solutions. That means they're the same line. So if I were to put them in slope-intercept form, they would be the exact same line. So once that number equals the same number, infinite. Does that make sense? Cool. All right, last one we're going to do is elimination. So I'm going to go through the first one with you, and then I want you guys to try the next two on your own. So elimination is when we're eliminating a variable, right? So if I was eliminating somebody from this class, I'm getting rid of them. And so this is definitely a skill where you can't just do it once and remember it. It's a skill that you're going to have to practice at home. So first I look at the x's and the y's, and I figure out first, are they lined up? Are the x's and y's on the same line? If both x and y are on the same side, who can raise their hand for a brain buck and tell me what type of form are they in? Standard form. So we want to make sure that x and y are on the same side so that they're in standard form. So are they in standard form? Yep. Then I try to make my match. So that means I'm trying to find what coefficient. They need to be the same. Remember, opposites attract, so they need to be the same number, different sign. What's going to be easiest to play around with to get to be the same number, different signs? The x's or the y's? The x's. So I know if this bottom one is negative 4x, that means this top one needs to be 4x. So I need to figure out which one. If I were going to do the y's, it wouldn't be wrong. You can do 24 and negative 24, but you would have to multiply both equations. You would get the same answer, just be more work. So what do I need to multiply to x to get it to be 4x? 4. And so the biggest problem I saw lately is that you're not multiplying to every single number. So 4 times 3y is 12y. 4 times 7 is 28. So make sure you multiply to each term in that equation. Do I need to do anything to the bottom equation to get it to be negative 4x? Or is it already like that? It's already like that. So I'm just going to rewrite that equation. This is what we learned last class. Then what do I always do to those two equations? Multiply, add, subtract. What do we do? What do I put right here? Anyone remember? I add things out. I'm always add. So when I do that, 4 minus 4, that eliminates. That's the point of doing this, so that we can eliminate something. So 4 minus 4 equals 0. It eliminates. What's 12 plus negative 8?
4.
Good. 4y. And then 28 plus negative 20? 8. Then how do you get y by itself? Divide, and you get y equals 2. So I know my y coordinate where they cross is going to be 2. To get my x coordinate, Tristan, what do I do? To get my x coordinate, what do I do? Plug it in. So I take either equation. I'm going to take the top one because it looks a little less complicated. So it says x plus 3y equals 7. I know my y is 2, so I'm going to rewrite it with y being 2. Then I'm going to solve. What is 3 times 2? And then how do I get x by itself? You end up getting x equals 1. So my solution would be 1, 2. How many solutions does that mean I have for that one? 1 solution. So I'm going to give you another 5 minutes, and I want you to try the next 2. So you know you're going to get the weird answers, like the infinite and no solution. So just be aware of that. But you're going to try to manipulate and do the same thing we did here for these. So go over this. Tyreek, what did you do first for the second one? So we figured out what pair do we want to play around with. It actually doesn't matter which one you do because the y's would be easy and so would the x's. Which ones did you choose, Terry? You used 2x. So that means this one needs to be negative 2x. Cool. Allison, what did you multiply to the bottom equation then? To make this negative 2x. Negative 2. So you multiply, you figure out, okay, what do I multiply to x to get it to be its little match, right? You're playing matchmaker. You're manipulating these equations. So that top equation, I would just rewrite. I don't need to do anything to get that pair to happen, right? But we got to change around that x. He's got to be negative 2x. We got to make our couples perfect, right? So I'm going to multiply negative 2 to x, negative 2 to 2y, which would get you negative 4y, and negative 2 to 3, which gets you negative 6. Who got that far? Give me a thumbs up. I saw most of us did. Then what do I do between those two equations? What do I do right here? Add them. So Kamari, tell me what you got. What did you do next? Once you get this. Add. And so what do I do? What happens? You get 0, so they eliminate. Then what do? What's 4 plus negative 4? 0, so they eliminate. And you end up getting 0 equals, what's 7 plus negative 6?
Oh.
7 minus 6. 1. Does 0 equal 1? Nope. So you should have gotten something like this, and it would be no solution. What type of lines are they if they're no solution? Parallel lines, they're never going to touch. Cool. Brandon, what did you do for this one up here?
Multiply by 2.
Multiply by 2. The bottom or the top? Bottom. Which 2 were you trying to get to be the same, the x's or the y's? The x's. So he saw 8x, and he knew he wanted to make his match by making the bottom one negative 8x. So they're always the same number, different sign. So to do that, we multiply 2 to each term. And so you would end up getting plus 2y equals negative 8. The top equation you already see is like that, so I'm just going to rewrite it. What am I doing between the two equations? Adding. And so what happens with the x's? They cancel out. What happens with the y's? What happens with the constants? You end up getting 0 equals 0. I remember 0 equals 0 kind of looks like an infinity sign, right? 0 equals 0. So when I see that, I remember, oh yeah, it's infinite solutions. They're always going to cross because they are the same line, same slope and line-intercept. So if you were to put those two in slope-intercept form, you would get the exact equation. Does that make sense? Okay, so what you're doing for the rest of this period, which is only 10 minutes, is you're working on the worksheet in front of you. So some of them are one solution, some of them are two solutions, or some of them are one, some of them are infinite, some of them are no solution. So you're solving each of these, so you'll see this is saying graphing, they even tell you what to do. The next is substitution, the next one's going to be elimination. And so you're practicing using these problems. You can use your notes as a guide, but this is definitely a skill that you can't just like, most of us can't just get by practicing in class. It requires you to practice on Delta Math outside of class. So you're practicing this for the rest of the period, and we are using this as a classwork grade. So you should be getting started now. And I'm going to come around.